Okay, so we're back, and this is going to be a slightly more advanced lesson in creating flip classrooms using Screencast-O-Matic Screencaster, as well as the Wacom Bamboo tablet that you can see details on in my PowerPoint presentation. Um, I've started off with Screencast-O-Matic and set it to the full-size HD. That allows me to cut out things that I don't want students to see, let's say on my desktop. I've moved into view my controls for my Bamboo dock, but outside of it are my other programs, documents, toolbar, time and date stamp, things like that that you may just want to keep out of view for a time being. You can bring things into view as I did with these, and you'll notice as we work through this video, some things will kind of open up and I'll do some resizing. I eventually will switch to a full screen once we have everything going. So um, if you get the Bamboo tablet, and your installation process will have to be completed on a work computer by the technology specialist at your school, because it does take administrative access to load everything in. So um, my fantastic technology expert, Margie, installed all this that you see here. And I'm going to go ahead and open up the Bamboo dock, and that's going to be all of our control panels. So there that is. And today, this is going to be advanced for some people, but if as you become more familiar with the Bamboo tablet or similar tablets like it, you'll notice that there's an unbelievable amount of versatility and options and things you can do. We're just going to go in and talk about like a basic creation of a mathematics lesson. I think that this format is good for, of course, math and then some sciences. You'll probably want to utilize some different things for English or social studies lessons or electives. As you can see over here, some of the basic stuff that they start off with includes altering pictures and just a regular paint program. There's this little game here called Free the Bird that I would recommend kind of playing around with at first when you get the Bamboo tablet. It helps you get a feel for the controls because it can be a little bit of an adjustment off of a regular mouse or even a mouse pad. But today we're going to go ahead and utilize the Bamboo paper, so I'm going to open that as well. And you can't quite notice, but when I open this, you cannot view the whole thing. So I'll move it up over to here and corner that in to your view. Um, there are still some controls outside of the frame that are hidden from you at this point in time. So actually what I'll go ahead and do is pause the video and resize to bring the full Bamboo paper into view, and then in a couple of minutes we'll resize to a full screen. So I'll go down to my taskbar and pause, and now you're in full view of the Bamboo paper. I moved a couple of items out of the way again so you can keep them hidden from your screencast. Um, so I'm going to come over here to my Bamboo paper, and I'm going to hit my little plus and say I'm going to start a new file, and we'll open that up. I like to select the grid paper. It makes for drawing a little bit easier, a little bit more neat. It's just my personal preference. I'm going to go ahead and stick with the blue colored, and we're good there. And at this time, I am going to go ahead and open up to a full screen. We'll open up the one page here, and I'm going to click to full screen. Now, as you can see, you're a little bit cut off. There's a full page over here, kind of comes down and cuts off. There's only a portion of a page. So I'll exit out of the full screen just by hitting the escape button. And I'm going to pause the video and resize my Screencast-O-Matic to full screen mode. And here we are. So, like I said, we're going to talk about some math, and we'll just use some basic algebra here. Let's say we're talking about 10x plus 5 is equal to 100. Now, for a lot of students, even when they're first learning algebra, it's not too bad. They know that they're going to go ahead and subtract 5 from both sides. What you do on one side of the equal sign, you do on the other. We'll go ahead and bring our 10x down. We'll combine like terms, and we'll say 100 minus 5 is 95. Okay? And we know that, hey, I need to get that x by itself. So we're going to divide by 10 and divide by 10 over here. What you do on one side of the equal sign, you do on the other. Cancels out. And x is equal to, let's say we're not quite sure. We're not in the everybody gets to use the calculator phase quite yet. 95 divided by 10. I get to put it on there. I got a 9. It gives me 90. 5 left over. Bring up a decimal point. 0 comes down. 50, well, I know that that's 5. And x is equal to 9.5. Page 2 over here, we can work out our check and say, okay, well then 10 times 9.5 plus 5 is equal to 100. And okay, we'll go ahead and say we need to do that multiplication. Again, maybe we're not using calculators quite yet. We're going to do this the long way, bring down the 0. We get a 5, we get a 9. Got the one decimal place moving out, one decimal place moving in. So I now have 95 plus 5 is equal to 100. And 100 equals 100. Yay for us. That checks out. We're good. I know I have the right answer, that 9.5 and x are the same value. Let's get that boxed in. There we go. Now I have the right answer. All right, so that's all well and good. I think that for the most part, these types of lessons that I'm going to show you are going to be fairly easy and straightforward. Now imagine you're one of those students who are first learning algebra, or you're a student with disabilities and you're learning algebra for the first time, and you go home and you're looking at your work page and it says 10x plus 5 is equal to 100, and you have no idea. You do not know what to do. And you can go back to your notes, and let's say that there's an example in your notes that you happen to write down, and it talks about, oh, let's throw a curveball in here, to y minus, get rid of that, minus 7 is equal to 103. And you're saying, hey, wait a minute, I don't get this. Why is there a y over here and an x over here? And now I'm dealing with minus as opposed to plus, and I don't know what to do, so I don't do anything at all. I believe one of the ways that we can use these flipped lessons is we can say, hey, instead of you wrote down all this math jargon nonsense, you have no idea what it's really talking about, or how to even begin, is you can create a lesson that says, well, let me show you this full example. Let me show you again how we work through these problems. Let me show you again, oh, let's talk about something more advanced. Let's say we're dealing with trigonometry. And we can say, hey, don't forget, just like I said in class, that your hypotenuse is directly across from your right angle. Well, something like that, the teacher again talking to the student, drawing in the same way that they saw in the classroom, not only brings forth the visual representation, the audio representation, they have their notes that they can use, but also a real-time, hey, there it is, it's across from there. And then maybe when we talk about sine and opposite over hypotenuse, they may remember sine and cosine and tangent. They may even remember the opposite and the hypotenuse, but the visual representation, the audio representation, and the real time cosine adjacent over hypotenuse is something that is really more getting towards that 21st century classroom. And the flipped classroom idea allows you to deliver a full lesson about, let's say, trigonometry, and we're looking to discover, uh, where the 3, 4, 5 right triangle comes from. So we'll say we're given the two sides here. We solve for the unknown side. We remind them again about Pythagorean theorem of a squared. There we go. Plus b squared being equal to c squared, where, again, hey, let's remind them that c is the hypotenuse side, big C is the right angle, a and b are somewhat interchangeable as far as the angles and sides, as long as our corresponding parts are correct. Okay, so let's say we were going to plug these in. 3 squared plus 4 squared is equal to c squared. 3 squared, of course, is 9. 4 squared is 16. Still bringing down our c squared. 9 plus 16 is 25. And let's say we get right here. It's a very, very common mistake for students to stop and say, oh, c must be 25. Well, we can remind them that we're actually looking for c, and this is set equal to c squared. So we'll show them, hey, we need to take the square root of both sides, getting us down to 5 is equal to c. So now that we know that 5 is equal to c, this is a 3, 4, 5. c is equal to 5. And we're looking for a little bit more discovery, a little bit more in-depth knowledge. We can say, okay, now let's try to prove this using one of our trig functions. Let's say we're going to use the tangent function. And we want to say, okay, what does angle B measure? We'll just go ahead and label that theta for right now. So the tangent of theta, we can refer over here to our SOHCAHTOA ratios and say that's going to be the opposite over adjacent. Opposite of theta is going to be 4. Over the adjacent side, 3. And we'll remind them, hey, we are looking for an angle. So in the calculator, we'll actually use our inverse function. And that will solve theta is equal to. And we can even leave this as in, what did you get? Have the students come in the next day, show us their work. We've worked out a bunch of it here. We're explaining to them this process. This is being done at home. At the beginning of class, instead of an activator or a warm-up that says, what did you learn? Students didn't learn anything. They didn't do their homework, leading to more frustrations on all levels. We can start with something like this and say, what did you get for this problem? We walked you through all the steps. All they had to do was punch in their calculator. Okay, you got it. Good. Let's move on. Let's do some practice problems. The idea of the flipped classroom is that the students take the lesson home with them. They learn it at night, taking the 10, 15, 20 minutes to work through a couple example problems. They come in the next day. Did you get the lesson? Did you understand what was going on? Show me that happened. Let's get that at the beginning of the class period. So now we can utilize the rest of our class period time to work through, to show them multiple ways that they are going to be presented with problems on quizzes and tests. Essentially doing the homework during the class period. This really allows for a new differentiated presentation to be made with harder concepts. As a high school math teacher, we come across this constantly. We teach them the lesson. They go through. The lesson goes bell to bell. We give them the homework. They go home. They don't know what's going on. So many teachers are finding this flipped method to be more successful, especially when trying to reach learners who may learn differently.